Thank you. I think the context of our presentation is really a call to action, looking for input from customers on what they'd like to see on this integration. We've taken this first step in building actually some stuff. And from my perspective, I think it's gone much faster than I really ever could have expected. But I think to get this thing out in the hands of people that really want to do stuff, we need more ideas on some of the use cases and what else you guys need to see from us. So we'll go here. My name is Jeff. I've been at Snowflake about 8 years. So what Snowflake is today is much different from when I started. So in 2014, I joined in 2015, really, Snowflake was a cloud data warehouse. That's what we were, right? It was natively built for the cloud, scaling concurrency, scaling performance, super dirt cheap storage. Like this is the kind of foundation of what the Snowflake database was. Because of the architecture, where all the storage is all in one place, there's some unique functionality that we have where you can share data sets among different accounts or different customers. So what that really did is change what Snowflake was. Instead of being just a data warehouse that was fast, and we say any workload, most workloads, it's an analytic database, not a transactional, super low latency database. But it's fast, it just works, which is kind of the line that you'll hear from all of our customers of kind of the killer app piece of it is the simplicity of making something traditionally very, very complex a lot simpler. But this second change that Snowflake went through, because of the architecture, being able to share data sets, this collaboration and data sharing, created what we're calling the data cloud, which is not just the platform itself, but it is data that is already in there, that's immediately available, updated in real time, that you can distribute or share between organizations or accounts. So that could be different divisions with your own company. It could be S&P delivering as default their data sets to their customers, right? And as we go along this path, right, it's not just the platform and data. We are moving the application building into Snowflake as well. So there's more functionality coming. So in financial services, this is kind of what the ecosystem would look like. It is, your company itself. There are data providers like FactSet, S&P that provide data sets in real time to you. There are solution providers that have built solutions on Snowflake that you can implement quickly. And there are 3 different cloud providers. So you're not locked into any different region, any different cloud vendor, whatever you guys want to move. Same code runs everywhere for us, okay? There's a lot of stuff I just skip over here because the conversation we were having yesterday is a lot of these, I guess, technical database limitations that we used to run into, I just don't deal with anymore, right? There's no indexing, there's no, for us creating clones, you can create near instant clones of any data set that you want to create non-production data sets. You can do all this interesting stuff. Okay, so basics again. And why are we going down this path? It really is because of customer requests on asking us to work with KX to get the technologies to work together. Why do they ask that? I think one of the key pieces is collapsing of platforms, right? How can we do more on fewer copies of the data, right? So if Snowflake is already holding a lot of the data in the organization, how do we bring workloads to that data instead of having to replicate that all around, okay? So that's kind of the first piece. Security and governance, okay? Snowflake is the data cloud, but really it's a NoSQL database, right? But it is built by database people. It is not a, in function, it really functions a lot like a functional data lake or a high performance data lake because of how it handles semi-structured and structured data. But the controls and the governance around it are what you would expect from an enterprise class database data warehouse, okay? So the more data that we can get into there, our customers can get into there and make that available to other use cases, the better. Okay, so this KX and Snowflake integration, as we go to this third stage where we're moving code to run within Snowflake. Traditionally, Snowflake is a SQL database. We interact with SQL, right? There's traditionally been a little bit of wiggle room on there. You can run JavaScript, you can run some stored procedures. But as we've moved to this building applications on Snowflake, moving Python code and other non-SQL languages to run within Snowflake is enabling other applications and other use cases. So this is how we've built this integration with KX. And Vibor is going to talk about how the integration is done. And again, my ask is, let's start these conversations. There's a ton of existing assets that may be valuable to run on data that's in Snowflake today. So if you have Q code that you want to run different types of workloads, either much more data or higher concurrency throughput, like these are things that we can do. Not the super low latency pre-trade analytics, but more forensic and deeper analytics. Okay, thank you.
Thank you, Jeff. So as Jeff mentioned, the driver of this integration is the ask from the customers to combine the two technologies together in some way so that there's no duplication of that data. Sometimes customers have been maintaining OLAP systems separate from a KDB database, taking data from OLAP, loading into KDB, run as of analysis, and push it back. As the data is moving into cloud, onto Snowflake, it gives us an opportunity and the extensibility that we have in the platform to run all languages. This gives us an opportunity to run something like a PyKX and Q code native within Snowflake. And that's what we tried to do in this, what we call a POC towards a pilot at a large bank out there. So our ask was, hey, let's test the speed, the flexibility of being able to run as of joins for 14 different time offsets on a couple of billion rows of quotes data, 80 million trades, and let's see what happens, how it performs. So that's what we set out to do. We loaded trades and quotes data into Snowflake. Now, Snowflake is a traditional database. It's a columnar database. It's not a time series database. So that was one of the tests to do how it performs in running loads like that. The other requirement was the code should not change. These firms have written Q codes for ages, and they don't want to be spending time, energy, and don't have the resources to rewrite the Q code. So the goal was to run an existing logic within the same framework. And that's what we did. So we use what we call Snowpark. Snowpark is Snowflake's extensibility framework, right? So moving away from just being a SQL-based engine, but being able to bring Python, Java, Scala, all these languages to run natively within Snowflake. And so we use Snowpark. We use the Q code that's pre-written, lock the file. The logic is to, again, run these offsets and bring them into the Snowflake. So you can bring any packages of your choice. We are natively integrated with Anaconda. So some of the packages right there, like a NumPy and a Pandas and PyArrow, are natively ingested. But Ashok mentioned yesterday that PyKX is opening up and integrating with Anaconda. So very soon, you will, just like we did for Pandas and PyArrow, you could just say packages equal to PyKX, and they'll natively run and invoked within the Snowpark environment within Snowflake. But for this POC, we did imports equal to the PyKX zip file, as well as the Q library that you have there, if you can point it, and then just wrote a stored procedure to run through the process of bringing the data into the Python environment and going through the execution. And the cool part of being able to write this as a stored procedure in Snowflake is, now this stored procedure could be called from any application, whether it's a SQL developer calling this application to run an as of join, whether it's some Java application. All you need to do is call the stored proc. It's a database object that now can execute natively within Snowflake itself. So this is kind of some of the syntax to be able to take the take the data, sessions.table, the quotes table, selecting the set of columns, and being able to bring it into the Python environment, and then converting it into a queue table, then bringing the logged queue file, kx.q, and run that logic natively within the Snowpark environment, and then being able to write the output back into the database all within the Snowpark environment. Now, this is where the parallelism of Snowflake comes into the power. So we have this ability to spin up multitude of compute clusters. By default, Snowflake auto-resumes and auto-suspends the compute clusters. And as these queries come in, it scales up. So in this instance, 8 nodes of 8 active Snowflake clusters spun up. There are 253 parallelized queries to process through this 1.5 billion rows, and then run the entire process natively within, as you see, it's spun up across multiple nodes and executing these queries in parallel. And at that point of time, about 258 queries running in parallel. So I was supposed to do this live and show you this process of running, but as it happens in live demos, something goes wrong. So at least I had some screenshots to refer this to you. But again, the process is being able to use this execute async function in Snowflake that allows you to parallelly distribute the execution and then sync up at the end for the data to be loaded into the final output table. So as Jeff was saying, the call to action is to identify some use cases. We believe that a lot of the workloads where you're doing shuffling of data between these multiple environments could be easily transformed into this framework. I would love to see some use cases within your organizations and do further deep dive with you. But the bottom line is we were able to make PyKX run natively within Snowflake, have the queue logic run in there, and we observed that PyKX ran much faster than just running pandas as a framework for doing this as of joins. So that's for our talk. We look forward to have a more in-depth conversation with you. Thank you.
One clarification. So the demo was not a technical issue. It was a license issue. We had a demo license. So that's why I'm not running this morning. Murphy's Law of it expired last night. So.
Insert your credit card.
Yeah. I've used that line many times, yes. So I think we have a couple more minutes. Are there any questions? Is this interesting at all, or what do you get?
You know, if you're running KDB and it's much faster, how are you going to charge your clients about that?
I think this is for, so to clarify on packaging, I am not the KX seller, but I would not expect this to be a free service, right, to run on Snowflake if there's value on it. But yeah, the licensing, I can't get into that one. That's on the KX team.
So I just want to clarify, the data is in Snowflake format, and this is just accessing that existing format. It's not queue loading KDB data in your cloud.
No, it's data's already in Snowflake. Oh.
So related to that, is it serializing from one format to another, or is it like really attaching to your data in memory?
No, the data is attached in memory, as you said. There is no conversion of the data. It's a native Snowflake format, or the columnar compressed format that Snowflake stores data.
Okay, so you built some integrations so you can read that natively without having to.
Right. Yeah. And in Snowflake, obviously, it uses the normal mechanics of spinning up multiple clusters and distributing all that. Nope. Anything else? Okay.
Thank you.
Yeah.
So you uploaded the Q code, but then you still had to write some Python code on top of that to use PyKX in order to get this to work. Is that?
So it's the PyX process of converting the pandas into queue and queue into pandas, those kind of conversions. But the process of sucking up the data from Snowflake is just normal Python code that you normally do in any SQL or Python engine.
Sure. Okay. Again, my ask is help us out. Like if there are use cases that you think may play, or if your organization has data in Snowflake that you want to get to, or reuse legacy code, or anything, we're open for conversations. Our head of product is interested in making this go fast. So, okay. Thank you.